All right, so now we're talking about math in Java. So we have discussed it a little bit when we've talked about just in and output, what happens to that math. But now we're going to actually perform more complex calculations. So these calculations are going to take place within expressions, and expressions in Java look like this. This is what we call an assignment statement. So an assignment statement has an equal sign, and the expression over here is being stored into or assigned the value to the variable on the left side. So the right always goes into the left. So you always have one variable over on this side equals, and then anything you want on the right side. So all expressions usually consist of operators, variables, and or literal values. A literal value being like the number 5 here, just a value floating around there, a number. So there's a few things that I want you to be aware of when you're doing this. Please do assign calculations to variables. So make sure you do assign, whenever you have any sort of calculation that's more than just adding two things together, put them into a variable, just like we did right here. This total divided by 5, that value, whatever that is being stored in average. Okay, perform calculations in a return statement. So that's the other one that I want you to do. Perform a calculation in a return statement. We don't know what a return statement is yet, but those of you that have done methods before or functions, you know that at the end sometimes you need a return statement, and it's always a good idea, shorten your code up a little to do it in the return statement. So why do we do these things in variables and return statements? So that you can use the value throughout your program. So when you write a program, say you want to compute the average you get in this class. So you write your program, you find the average of the class, then what happens? If you just do it in an output, all you do is look at it. If you don't, then you could send it to the school, or I could send it to the school to figure out your GPA, to figure out your rank in the class. You could send it to a college. All those things are useful. So that's why you want to store your calculations in variables and not just output them. So don't, as I just said, I think I can just do that, perform in output statements. Do not perform calculations in output statements. All right, so these are the operators that we use. There are more, but they use a math class, and we'll discuss that later. We have addition, subtraction, multiplication, division, and then modulus division. So addition we've done before. We've talked about how it works with strings and math. So you're aware of how it works in an output statement. Now we're just doing them in calculations. So modulus division here is the one that we will be discussing shortly. So first, integer math. So if you have two integers, so 6 and 5, or any sort of variable that's an integer plus an integer, minus, times, or divide, or modulus, the answer is an integer. So you have to be careful of that. If you have two integers, your answers will be an integer. So if you do something like 6 divided by 5 here, it's going to give you 1 and not 1.2. So you will not get the decimal equivalent. If you operate it on an int or on integers, the answer is always an int. Same thing with the double. If you operate on a double, so real math doesn't mean the other one was a fake math. This just means that we're using real numbers, so decimals or fractional equivalents. So anytime I do division, multiplication, and any sort of operation on a real number, the answer will also be a real number. So you see when I do this division, I will get a decimal equivalent. So where does the line get drawn? So if I divide 1 by 2 here, I will get 0. Even though 0.5 is what you get. So it does not, what this is showing here, it does not round. So if you do 1 divided by 2, you get in your calculator 0.5. But since both of these are integer constants or literals, it doesn't care about the decimal. It just says 1 divided by 2 is 0, and that's it. So just be wary of that when you're doing calculations. So if you divide 2 decimals, you will, however, get that constant. Even though technically this is still 1 divided by 2, this is a larger value of precision, so it does allow you to have a decimal answer. So just keep in mind when you're doing this, as long as one value is a decimal, the result is a decimal. So it doesn't matter which one. So in this particular case, if I did 1 divided by 2.0, I would get 0.5. Or if the 1 was a decimal, you would get 0.5. So as long as one of them, you will get a decimal equivalent. So it takes basically, if you have 2 values that you're performing a calculation on or more, it takes the largest one. So if you have a double, an integer, a long, the double is the one that took the most amount of space to store. So that's the one that's going to be like the end product. Okay, just be careful of runtime errors, and you get a pretty nasty runtime error when you divide by 0. So, when you divide by 0, that is an error. And runtime means it's not a syntax error. It's not going to stop the program from running. But what it will do is when the program runs and it reaches this line of code, it will blow up. No, I'm just kidding. It will combust. But if you divide 0 by 1, that's 0. That's not a problem. Okay, then we talk about modulus division. Modulus division is modulus gives you a remainder. So modulus division, another name for the result, is the remainder of the division problem. So 2 divided by 3 is not the most clear one that you can look at. So I am going to attempt to do a few examples here with my little stylus that I am growing more and more annoyed with. All right, so I'm going to talk about 45. All right. Right, for the love of God. I am on the pen. Oh, because I'm writing in white. It's all right. We got this. I got this. All right. So we're going to do 45. I'm going to punch someone in the face. Wish I could edit this out, but I can't. Go up. There we go. 45 and 7. So we're going to talk about 45 divided by 7 and 45 modulus 7. So let's do this. If I divide here, if I take 45 and I divide it by 7, I get 6, and I do the math here, multiply those two together, subtract, and I get 3. This right here is the answer to the division problem. Okay, remember, these are both integers, so when they're both integers, the result is an integer, no decimal happening. So it's just the division problem. Down here, it's not the decimal value, like you would get in your calculator, the dots, what comes after the decimal. It is literally just the remainder. So this is the answer to the modulus program part. Okay, so just quickly with a couple others. Hopefully this doesn't combust on me. So say let's try 72 divided by 6 and 72 mod 6. So when I do this, I take 6 into 72. So the top answer that I get in the end here, hopefully you all remember how to divide. So this is the answer to this problem. And down here is the answer to this problem. Pretty fancy. Okay, just one more real quick. I'm on a roll here. Let's see if it keeps going. Let's say I do something strange, like 5 divided by 7. And 5 modulus 7. Now, when would I ever use that? Well, say we were going on a trip, and we needed 7 people in a group. Now, if only 5 people showed up, how many groups would there be? Well, hopefully you realize there'd be 0 groups. There'd be no one going on this trip. And the remainder would be 5. Okay, so when this number is smaller than this number, so if the divisor is bigger, you will get 0 possibilities and 5 and the amount left over. Okay, so with this one, hopefully you see num has to be an integer here for it to give you the integer response. So num modulus 10 would give you 5 because that's the remainder here, and num divided by 10 would give you 4. And note here that it's interesting that you would get 4, which is the tens digit, and 5 here, which is the ones. Please note that if you do modulus division on a real number or a double, it will give you the straight up decimal piece. So it will give you this. Interestingly enough. Okay, so if they're both integers, you will get the remainder. If they're both, if one of them is a double, you get the decimal remainder. All right, have a great day.